Good afternoon. My name is V. Pradeep Reddy and my roll number is 2095182151 and I am from Aeronautical Engineering branch 7th semester. Subject techniques in wind tunnel testing and topic is vehicle body aerodynamics. Abstract. The constant need for better fuel economy, greater vehicle performance, reduction in wind noise level and improved road holding and stability for a vehicle on the move has promoted vehicle manufacturers to investigate the nature of air resistance or drag for different body shapes under various operating conditions. Aerodynamics is the study of a solid body moving through the atmosphere and the interaction which takes place between the body surfaces and the surrounding air with varying relative speeds and wind direction. Aerodynamic drag is usually insignificant at low vehicle speed, but the magnitude of air resistance becomes considerable with rising speed. Viscous airflow fundamentals. Boundary layer. Air has viscosity, that is, there is internal friction between adjacent layers of air whenever there is relative air movement. Consequently, when there is a sliding between adjacent layers of air, energy is dissipated. When air flows over a solid surface, a thin boundary layer is formed between the main airstream and the surface. Any relative movement between the main airstream flow and the surface of the body then takes place with this boundary layer via the process of shearing of adjacent layers of air. When air flows over any surface, air particles in the intimate contact with the surface loosely attach themselves so that the relative air velocity at the surface becomes zero. This is a graph comparing resisting forces opposing motion versus vehicle speed. Okay. See that higher resistance CD is 0.5, lower resistance CD is 0.25 and rolling resistance is CD equals to 0. Comparison of low and high aerodynamic drag forces with rolling resistance. Skin friction. This is restraining force preventing a thin flat plate placed edgewise to an oncoming airstream being dragged along with it. In other words, the skin friction is the viscous resistance generated with the boundary layer when air flows over a solid surface. Skin friction is dependent on the surface area over which the air flows, the degree of surface roughness or smoothness, and the airspeed. Surface finish. Air particles in contact with a surface tend to be attracted to it. Thus, viscous drag will retard the layer of air moving near the surface. However, there will be gradual increase in airspeed from the inner to the outer boundary layer. The thickness of the boundary layer is influenced by the surface finish. A smooth surface allows the free airflow velocity to be reached nearer the drag surface, whereas a rough surface widens the boundary so that the full air velocity will be reached further out from the surface. Hence, the thicker boundary layer associated with a rough surface will cause more adjacent layers of air to be sheared. Accordingly, there will be more resistance to air movement compared with a smoother surface. Influence of surface roughness. A figure is rough surface and B is smooth surface. You can see that boundary layer formation is more on the rough surface compared to the smooth surface. Front end nose shape. Optimizing a protruding streamlined nose profile shape influences marginally the drag coefficient and to a greater extent the front and lift coefficient with a downturned nose. The streamlined nose profile directs the largest proportion of the air mass movement over the body and only a relatively small amount of air flows underneath the body. If now a central nose profile is adopted, the air mass movement is shared more evenly between the upper and lower body surfaces. However, the air viscous interference with the underfloor and ground still causes the larger proportion of air to flow above than below the cast body. Conversely, a upturned nose induces still more air to flow beneath the body with the downward curving entry gap shape producing a Venturi effect. Consequently, the air movement will accelerate before reaching its highest speed further back at its narrowest body to ground clearance. Aerodynamic lift control. Underbody dams. Damming the underbody to ground clearance at the extreme rear blocks the underfloor airstream and causes a partial pressure buildup in this region. Whereas locating the underbody dam in the front end of the car in the rear low pressure wake region with the underfloor space, thus with the rear and 606 ground underfloor air dam, the underfloor airflow pressure increase raises the aerodynamic upthrust, that is, it produces positive lift. And as would be expected, there is also a raise in drag as the frontal areas of the dam is enlarged. Thank you.